All right, so we have primitives, okay? Primitives are stored exactly in memory. And I'm gonna do a more memory fairy tales for you that are pretty much accepted. So you can don't worry about, you can mention them at your computer science parties and people will be like, yes. But they're fairy tales. Don't get it twisted. Okay. I'm gonna say that we have our memory here, okay? And in our memory, we have different programs running. So here I have QuickTime running, for example, and that's loaded into memory. And then there's a bunch of variables and stuff that are being kept track of in QuickTime. And then I have Safari in memory or whatever, because I'm going online. I never use Safari, except when I do examples in class, and then I don't use Chrome, I use Safari in the examples. I don't know why. Just telling you, give me a little insight to how these videos are made. And then we have our Java program, okay? And then maybe down here we have some other program. What other stuff do I have? We have a video game, StarCraft. Do any of you play? Someone play StarCraft? I know. Remember, I talked to a student about playing StarCraft. And they were good. Oh no, they played League or something. League or Star, I don't know. Okay, doesn't matter. Java programming, okay? So our Java program is there. And then we say int x equals 10, and our Java program knows how much memory each of these primitives that we have in our program are going to take, because primitives don't change values. And so all of them are just going to be here, x equals 10, etc., 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 okay? We have enough space for all of these things, okay? Now, here's where things get interesting, all right? We actually don't know how much space we need in this Java program. And I can give you a quick example, right? So let's say I wanted to make a number, so what I'm going to write a program where the user clicks somewhere in processing, and I take that value, the x value they clicked at, so the user clicks here, and so that x value is, I don't know, like almost to the width of the thing, and it's 200 by 200, so that x value is like 150, all right? And I'm going to make a can of balls, right? So ball array can of balls, right? Ball array can of balls, and equals new ball 150, okay? So the only reason we have 150 balls, right, and then we can call the constructor on them using a for loop. The only reason we have 150 balls is because that user clicked that place, right? The user could also click over here in another run of the program, and then maybe we would just have 15 balls in this array, okay? Now, this is a very contrived program, but we could actually make it less contrived, okay? You could ask the user, how many balls do you want on screen? Okay, and then the user could input how many balls they want on screen, and then we could make an array of that number of balls, okay, and make them all random values and then set them off on the screen, okay? But, you know, if they write 15, we just need space for 15 balls. If they write 900, clearly our program is going to be a lot bigger, okay? And here's the interesting thing. This was not determined when we compiled the program. This is determined at runtime. It's like we need to be able to quickly create memory on the fly to handle the 900 ball array, okay? But we don't have that memory necessarily. I mean, our Java program is stuck in between Safari and StarCraft, right? And we have enough stuff for all the primitives, but we don't necessarily have enough stuff for all the objects, okay? Again, this is a fairy tale. Don't think that it's legit. So, what does that mean? How does Java or other languages solve this problem? Well, Java solves this problem with a thing called object types. Okay, and object types work on the idea of references. So they're also called reference types. Okay, and what's a reference? A reference is just another way to say a memory address. And what's a memory address? Well, that's every variable or piece of data in memory or piece of data in memory is addressable. Has a location. Okay? And so there's some number to some other number, and that's all the memory in your computer, running memory. And so when programs are loaded into memory, we have all of these things are loaded. They all have locations. So this x equals 10, for example, we said was at 0x447 or whatever it is, right? And we're gonna call we're gonna say all our memory locations are gonna have this form of 0x something something something. It's just a way to say that they're gonna be hexadecimal numbers, which we can talk about some other time. All right, but it just makes it a shorthand so that we don't have to write a giant memory address. So this x equals 10 has a memory address. Okay, and so it's in a memory address, this. And if I say something like double y equals 15, it'll have a different memory address. Okay, y equals 15.0 if it's a double, right? And what will that memory address be? I don't know, 0x992, something like that, okay? All right, so that's good. We have things that have memory addresses, okay? But then what happens if I say I want a ball array, can of balls, and I want it to be 15 in one run of the program or 900 in another run of the program? Well, clearly, I don't know. I can't plan for the 900, or what if next time the person comes in and says, I want 300 balls or 900 balls or 2,000 balls or whatever that case may be. I can't plan for that here. I can't just say you can have whatever memory you want, okay? So what do? Well, I make a placeholder, okay? So ball, can of balls, right, whatever. I make a placeholder, and what does that placeholder say? Well, it says we're gonna run out of memory here, but there's a magical place with infinite amounts of memory. And it's not magical, it's just the bottom of the memory, okay? So if we're loading in programs on the top of our memory, at the bottom of our memory is where things are free, right? Unless we're running out of memory, things are free down here, okay? And you can run out of memory. We'll do it. We'll do some experiments with that. It's a Java. It's again, fairy tale world, okay? But we can make that happen. And my can of balls is going to have a thing that says 0x 99972 or whatever, okay? And what that is so notice x equals 10, y equals 15, and can of balls is an array, but it's not equaling an array of balls, it's equaling some memory location. And if we go to that memory location, and that memory location is stored here at the bottom, okay? And if we go to that memory location, we will find all the balls, okay? And this is called the stack, and the stack grows down in memory, and this is called the heap, and the heap grows up in memory. Okay? Again, fairy tale. All right, and in this way, since we're able to reference the bottom of the stack, our Java program is this static amount of memory here in the stack, but it's referencing things that are on the free store that is infinite amounts of memory. Okay? So it would be a little like, I don't know if if there's like stores like this anymore, but like it would be like you go to a store. There used to be stores where like they wouldn't have the items in the front. They would just have like these cards or something, and you would go and you'd pick up the card and you'd say, okay, this card represents a stapler, and this card represents a notebook, and this card represents whatever. So their storefront could be like really sparse, and you could just like be like, okay, these are the items I want. And then you'd give it to the people, and then they'd go back into the warehouse and grab those items and bring them back out. The warehouse being like free store, right? And this reference being like a placeholder which tells you where the item is, or placeholds for the actual item, okay? So here's the big lesson here, and there's a few things here, okay? Oh, you know what? You know who does that? I think GameStop does that. I think with GameStop, I haven't been to a GameStop in so long. I know all you Wall Street bet kids out there are like all into GameStop, but I kind of believe that, or like video game stores, you would like bring a box or something, but it'd just be an empty box because they didn't want people to shoplift, I guess. So you bring the empty box up, and then they put the video game inside afterwards. It's a little like this, right? It's just like, okay, this is a placeholder, but the actual items are going to be put in some place where we actually have the space for them, and which could be any amount of space, because who knows how big they're going to make the can of balls. Okay? So then we have reference types, okay? And our reference types all have capital letters. Okay? And now we know what this keyword does, okay? So this keyword invokes the constructor, but new is a special keyword that says, give me new memory on the heap. Okay, so our Java program has a certain amount of memory that we know it needs to run, and that's consisting of our primitives. And then all of a sudden we have this special kind of memory, and that's what new says. New is actually saying, make me that memory down here for this object, okay? And then, you know, you call ball, which is the name of the constructor, right? It's also the name of the class, but it's the name of the constructor. And you pass in the values, and those values will go into the constructor for ball. And remember, the constructor sets the private variables. Okay, so this is not I'll change this to my ball right now, just to make life easier. And my ball references 0x997. If we go to 0x997 in memory, we have a ball. That's where my ball is pointing to, right? Reference, I will also say pointing, and that's a C++ term. In Java, they're called reference. In C++, we say pointing to. It's also called reference in C++, but we say pointing to because they're actual pointers. They are pointers here in Java too. Like these reference types, this is a pointer. It's pointing to memory. Okay, and so that's why we call it a pointer. So if you hear the word pointer, think, okay, it's like it's holding a memory address. All right, and so if we come down here to the memory address it's holding, well, we'll find a ball. And what does a ball consist of? Well, we'll find an integer for position x and an integer for position y, and all of these things will be here, and they'll all have values based on, or initial values at least, based on our constructor. Okay. So think of this, the big things you need to understand here, okay, are we have primitive types, okay, where we hold the value, we make the value directly and we hold the value directly, okay? And we know our primitive types with the lowercase like letter at the beginning. We have object types, okay? And object types, okay, reference, so we store, they hold memory addresses, and then when we say new, we give it memory on the heap, and then calling the constructor will set the values of all the private variables, and those are stored on this special memory on the heap that is pointed to by my ball. Okay? So what does this mean? What are the implications of our object types? Well, I don't want to overload you just yet, so I'm going to ask you a few questions down below, and then I'll see you next video where we will talk about object types.